but I'll be on it always, always.
Hi, welcome back. On this video, we're going to do balancing equations by using the counting method. So in my last video, I show you the examples of how to balance your equation by using the box method. But in this video, we're going to do the counting method, okay? Which happens to be my favorite one because I can just see what I'm doing, plug and chug, and I'm on to the next, okay? So, but whichever one is your thing, do you, okay? So we're going to start off with the example P plus O2 yields P4 O10. Now the first thing that you're going to do is go ahead and draw a line at your arrow sign. That way, or your yield sign. That way you're separating your reactants from your products. Now down here, I'm going to put at the bottom how the left side is your reactant and the right side is your products. So this is the side that your products is on, okay? Left side. Now this is a quick note for those of us that need a quick refresher, okay? But this is information you should know. All right, so starting off, I'm going to go ahead and create a list of each element that I am utilizing in this equation. So I have P and O, okay? So the way that I set my P and O up on my reactant side, I'm going to do the same thing on my product side. And it's not law, but this is a way that I utilize because it just helps me to see everything without looking all over the paper, okay? So now I'm going to identify how many of each element is actually present. So on my reactant side, I see that I have 1 phosphorus present and then I have 2 oxygens present. You are able to identify the number of atoms that is present by looking at your subscript. So that 2 for oxygen comes from that subscript that is next to oxygen. If there is no subscript next to that element, that means that it is just 1. All right, now we go over to the product side. I see that I have 4 phosphorus present and then I have 10 oxygens present on the product side. When I look and then I look from my reactants to my product side, I see that my elements do not match, which means that I have an unbalanced equation. So now I have to balance it. Now, when it comes to balancing with the counting method, you want to utilize what we call coefficients. Your coefficient is the big number that you're going to put, you see where these lines are at, in front of your element or your compound. Now, you're going to use a number 1 to infinity, which you won't ever have to use infinity, but you're going to use a coefficient that you can use as a multiple to multiply by your subscript that will allow for you to become balanced. So I'll show you what I'm talking about in just a few, okay? So first things first, we read our equation from left to right, okay? So with that being the case, we're going to start from the left and start with the element P. I noticed that on my reactant side, I only have 1 phosphorus present, but I have 4 on my product side. Now I want my elements to match. So with that being the case, I have to now find a coefficient that I can use as a multiple to distribute to my subscript for P, which is 1. So what is a coefficient that I can use, a number between 1 and infinity that I can use to multiply by the subscript 1 that is going to give me 4? Well, we know that that will be 4, right? So if I use the coefficient 4 and multiply it by 1, the subscript 1, I am going to have 4 phosphorus on my reactant side. So now I got my phosphorus balanced by using my coefficient. Next, I got to go to my oxygens. On my reactant side, my oxygens only have 2. But on my product side, I have 10. So now I have to find a multiple that I can use to multiply by 2 that is going to give me 10 to match my product side. And what I know is that 5 times 2 is going to give me 10. So I am going to use 5 as the coefficient to multiply by my subscript 2 in order to get my 10 oxygens. And just like that, I am done. Now, here on my product side, where this box right here is still empty, you can either leave it empty or put 1. All right? You can put 1. Pretty easy, right? Well, y'all can't respond back to me, but you can leave it in the chat. Like, yeah, it's pretty easy. All right, so let's do another example. So we have Al2O3 yields Al. Oops. Let me go ahead and erase that. Al plus O2. Right? O2. So now, first things first, I'm going to go ahead and separate my reactants from my products. Next, I'm going to go ahead and write out a list of each of my elements that is in my equation. So now that I have that set up, I'm going to now identify how many of each element is on both sides. So I have 2 ALs on the reactant side and 3 oxygens on the reactant side. 1 AL on the product side and 2 oxygens on the product side. When I look, I see that I am not balanced. My elements do not match. So now I am going to only change my coefficients. I'm not going to change nothing else. I can't change my subscripts in order to become balanced. I can only change my coefficients. Okay, that is all. So I see that I have 2 ALs on the reactant side, but I have 1 on the product side. And now because I read my equation from left to right, this is where I'm going to start. Okay. So I know that if I have 2 ALs on the reactant side, I want to get 2 on my product side. So I know that the coefficient 2 is what I can use for my AL over here, okay, on the product side to multiply by the subscript 1 that is going to give me 2. So now it's feeling good. My ALs, they're balanced. Woo! All right. But then I go to my oxygens, okay? So my oxygens, this is where it get a little tricky because my oxygens now have an odd number. I haven't dealt with an odd number so far, okay? So I have 3 oxygens on my reactant side, but 2 on my product side. And with that being the case, I know that there's no multiples that I can use as a coefficient that is going to allow for my product to get to 3 when I already have 2. It's no number that I can multiply by 2 that's going to give me 3. So with that being the case, I now am going to find different multiples that will be common that I can use between my reactant and my product that will give me the same amount of oxygens. So I know that if I multiply 3 times 2, so I'm going to use the coefficient 2 here, okay, that will give me 6. 3 times 2 is 6. So now I have 6 oxygens on my reactant side. But then when I go to my product side, I know that if I use the coefficient 3 and multiply it by 2, the subscript 2, that will also give me 6. Uh-oh. Oh, snap. You see what's happening here with my counting method? I'm using coefficients that I can use as a multiple to multiply by my subscript, all right, to help me get to a common number that my elements can share, all right? Now, my oxygens, they match. But now because of this 2 being in front of this Al2O3, that 2 also has to now be distributed to the subscript 2 in AL. So now that changes my amount of ALs, okay? So since that changes my amount of ALs, I now have 4 ALs on my reactant side. And since I now have 4 ALs on my reactant side, that means that this 2 that I had over here, I got to go ahead and erase that. And now I have to find a multiple that I can multiply by 1 that's going to give me 4 so that it can match my reactant. And I know that that is just 4. And now I have my 4 aluminum. And as you can see, it checks off the boxes. I am now balanced. So I hope you can see that sometimes some of the coefficients that you might start off with may not be what you end with. But if you continue to just trust the process, you will get to exactly where you need to be. All right. Now let's do one last example that I think is a bit tricky, but it's something that we can't handle, you know? All right, so we have Ag and O3 plus CaCO2 yields AgCl plus CaNO3 too. All right. So let's get to it. All right. So we're going to go ahead and separate our reactants from our products. Okay. At this point, we should be masters of separating our reactants from our products. And then we're going to go ahead and write out a list of each of our elements. Okay. So we have Ag, we have nitrogen, oxygen, Ca, and Cl. Okay. Yes, you must separate every single element, even if it's a part of the compound. Separate them to individual elements. So I'm going to write out the same list in the same order on my product side because I want to be able to see what I'm working with. Okay. Especially when it comes to the counting method. So on my reactant side, I see that I have one Ag, I have one nitrogen, I have 3 oxygens, 1 Ca, and 2 Cls on the reactant side. Then I'm going to go to my products. I have 1 Ag. And now when I go to nitrogen, I notice that nitrogen has a subscript that is outside of the parentheses. Now when we're talking about distributive property, we know that everything that's outside of the parentheses has to be distributed to everything that's inside of the parentheses. So with that being the case, I know that this 2 has to be distributed to this 3 as well as to that 1, okay? The subscript 1 next to nitrogen. So with that being the case, 2 times 1 is 2. So that lets me know that I have 2 nitrogens here. So this 2 outside of the parentheses is very vital to understand how many of each element that we have, okay? And then 2 times 3 is 6, so I have 6 oxygens on my product side. I have 1 Ca, and then I have 1 Cl. Okay. Now I read my equation from left to right, and as a result, I am going to now find out different coefficients that I can use to get my equation balanced, because as I can see, my elements do not match, and I want them to match. Okay. So I have my AGs, my reactant Ag and my product Ag, they match so far. So nitrogen, sorry, give 1 second. Okay, so nitrogen, okay, I have 1 nitrogen on my reactant side, and then I have 2 nitrogens on my product side. So as a result, I now know that I want to find a coefficient that I can put in front of this AgNO3 to give me that 2 for my nitrogens. So I know that if I'm looking for 2, I'm just going to go ahead and put coefficient 2 in front of my compound AgNO3, right? Because this 2 has to be distributed to all of those subscripts as a multiple in order to get what we need. So 2 times 1, the subscript 1 for nitrogen is 2. So now I have my 2 nitrogens. But now that I have my 2 nitrogens, I also now have to distribute this 2 to all of the elements that it is in front of. So now I got to distribute this 2 to this Ag. So now I have 2. And then I also have to do the same to this 3. So 2 times 3 is 6. So now I have 6 oxygens, okay? So now that is taken care of, I have to go back because initially my AGs, they were once balanced, but now they aren't anymore. So now I want to get my AGs balanced before I try to move forward, okay? And so now I have 2 AGs on my reactant side, but only 1 on my product side. And the only way to get that balance is to use the coefficient 2. Use the coefficient 2. So 2 times 1 is going to be 2. So now I have my 2 AGs, okay? I have my 2 silver, okay? Now that this 2 is in front of this AgCl, I now have to also distribute this 2 to the CL, okay? So CL has a subscript of 1, so now I multiply this 2 times that 1, and now it's going to give me 2 CLs, all right? So now I want to just go ahead and check to see if I'm all balanced out, right? So AG, it has its 2, I'm good. N has its 2, I'm good. My oxygens has its 6, I'm good. My CAs are good, and my CLs are good. So now I am balanced, baby. Please don't play with it. I'm balanced. And since I am balanced, that means that the places where there's no coefficient, it means that it is just 1. It does not mean that it is 0, but you do not have to put 1. So boom, we are finished just like that. Okay. I hope that this really helped you. If you're still confused, please just take the opportunity to go back through either the box method or this counting method video, and please just take your time, okay? This is what helps me. Please give yourself grace and understand that it just takes practice. Please do not find yourself frustrated and wanting to be overwhelmed and giving up. If you need to, go ahead, pause from this video, take a 5-10 minute break, watch your favorite TV show, and then get back to it, okay? Good luck on your test, and I'll see you in the next video.
Don't play with it, don't be dishonest. Still not